So in chemistry, we use significant figures to show how precise our measurements are. So we use rules to determine how many decimal places should be in the final answer of a calculation. Significant figures indicate how precise our measurement was to start with. So if we report a number that has too many significant figures, it looks like we were more precise than we actually were. If we report too few significant figures, it looks like we weren't very precise. So we want to give enough significant figures to be precise enough for what we're trying to do. So there are rules that determine how many significant figures are in a number, and then we're going to talk about how to know where to round off when we do a calculation. The way we determine how many significant figures we have is all non-zero numbers are always considered significant. So 1 through 9 will always be significant. For zeros, that's where it gets a little bit tricky. Whether or not zeros are considered significant depends on where they are in a number. So we're going to talk about 3 different types of zeros in a number and how we know whether or not they're significant. Before we get there, I do also want to mention really quickly here that sometimes we have exact numbers. So exact numbers are things like 12 eggs or 12 inches in a foot. We sometimes refer to these as counting numbers. So for example, 12 eggs, you could count that you have 12 eggs. Or if I have 6 chairs in front of me, I can count that there are 6 chairs. So if you can count how many there are of something, it's an exact number, and we consider that to have an infinite number of significant figures. So we don't have to worry about that when we're determining how many significant figures to give in an answer. For zeros, there's 3 different types of zeros. There's leading zeros, trailing zeros, and captive zeros. So leading zeros are those zeros that are at the front of a number when we have a decimal. Leading zeros are never considered significant. They're just placeholders to show us where the non-zero numbers actually start. So for example, 0.00392, these zeros here at the front are not significant because they're just placeholders. So only the 3, 9, and 2 are considered significant. So we have 3 significant figures in this number. For the next number here, we have a 0 before the decimal, and then we have 5 zeros. It doesn't matter how many zeros are there. If they're leading zeros, they're not significant. They're just placeholders for us. So we have 5 places between the decimal and the 4. Only the 4, 5, 6, and 3 are considered significant. So this number has 4 significant figures. For trailing zeros, sometimes they're significant and sometimes they're not. Trailing zeros are those numbers at the end of a number. If there's no decimal point in the number, like in the number 3700, zeros are not considered significant. So 3700 only has 2 significant figures. If there is a decimal point, then the trailing zeros are considered significant. So 140.00 would have 5 significant figures because the 1, 4, 0, and the 2 zeros after the decimal are all considered significant. Captive zeros are those zeros that are in the middle of a number. Those zeros are always considered significant. They're in between non-zero numbers, so they're trapped there. And the non-zero numbers around them are significant, so those captive zeros are also significant. So 16.07 would have 4 significant figures. 20.007 would have 5 significant figures. So leading zeros are never significant. captive zeros are always significant. So those are two cases where once we determine what type of zero we have, we immediately know whether or not it's significant. The only time there's a choice is when we have trailing zeros. So if there's a decimal, the trailing zeros will be significant. If there's not a zero, they won't be significant. So let's take a look at a few examples here. If we have the number 100 pounds, there's no decimal in this number, so those trailing zeros are not significant. So 100 pounds would only have one significant figure. 350.0 has a decimal, so those zeros are significant. So this number would have 4 significant figures. 0.0035, those are leading zeros, so those are never considered significant. So this number only has one significant figure. 10,000 is just like 100. There's no decimal, so there's only one significant figure. If we change that to 10,001, now we have captive zeros, so all of these numbers are significant. So there's 5 significant figures. So I'm going to let you try the last one on your own, and we'll get some more practice with this in class. We also need to look at, when we do calculations, how to round off. So when you're doing multiplication or division, the answer is limited by the least number of significant figures. So the rule is that you can only be as precise as your least precise measurement. So for example, in 278 has 3 significant figures. But if we look at our number of gallons, we have 11.70. There's a decimal, so that trailing zero is significant. So this has 4 significant figures. So we can only be as precise as our least precise measurement. So when we calculate 278 divided by 11.70, we get 23.7606, and this number goes on and on and on. But we're going to round to 3 significant figures. So the 6 would round the 7 up to an 8, which means that we would have 23.8 miles per gallon. Now when we add or subtract, we go by the number of decimal places. So we're limited by the number with the smallest number of decimal places. So if we add together 3.18 plus 0.01315, the 5 is considered significant. The 1 is, actually, we'll figure out what's significant once we add these together. So 5 plus nothing is 5, 1 plus nothing is 1, 3 plus nothing is 0, 8 plus 1 is 9, 1 plus 0 is 1, and 3 plus 0 is 3. So 3.18 only has 2 decimal places. Our other number has more decimal places, but we're limited by the one that has the least number of decimal places. So we would round this off to 3.19 for our final answer. So there's a few more examples here. So I'm going to give you a chance to work these out. So I want you to try these on your own. And then we're going to get some more practice with this, as I said, in class.